this is our first class of physics. It is of class 7th standard book, and it is for ICSE schools, printed by Goel Brothers Prakashan. ICSE board approved this, but it is not the NCERT book or CBSE book. But the books are very good. Whatever the publications, last year some other publications were there, no? No, it's not Goel Brothers Prakashan. Last year some other publications were there. So whatever it is, I am teaching my daughter physics. So I think it may help some others also. So it's a relation between fathers and daughters. So the channel's name is also Physics with my father. So this is the first chapter, physical quantities and measurement. Already we have discussed, Nama. Lots of units, about units, lots of areas and other topics has been discussed earlier last year. So in class 7 also there are some reminder of this, and let's start through line by line. Physical quantities and measurements, learning outcomes. What we'll learn reading this chapter actually. Measurement of area. First they have started with measurement of area. What do you mean by area, ma? What do you think?
The space occupied by an object.
The space occupied, actually it's not space. If you say space, it's relates to volume. Whenever you say space, suppose this one has occupied some volume, then what is area? It's a flat surface. Area means you can relate it to surface, not space, only surface. So we have already learned measurement of area in class 6. Let us revise it and find the area of irregular surfaces. Surface means, okay, area means its surface. We know that area of door is more than that of window. Similarly, the area of table is more than the area of chair. How can I make the above statement with assurance? Is it true always? How can we define it? We have seen the window, we have seen the door, so we can assume there is a large difference. The size of both the object is largely different, so we can assume that what is bigger, what is smaller. But in some cases, you can't find it just observing the objects. So how can we assume? How can we find the area? Before we learn to measure the area, let us try to find out what do you really mean by the term area? Area. The amount of surface occupied by an object or a place is called its area. I already told you, area means surface, not space. Surface. Okay. Investigation 1.1. Let us try to find out the area of the table and the chair. Place the physics books on the table side by side as shown in figure 1.1. Let us suppose that the 4 physics books cover the complete surface of the table. Thus, the area of the table is equal to the area of the 4 physics books. Now place the physics book side by side on the chair. Let us suppose that 2 books cover the complete surface of the chair. Thus, the area of the table is equal to the 2 times the area of the chair. Let's do this with this copy. How much area? How much area does this book has? Place this 1 and something here, 1, 2 and this much, 2 times of this copy, and you can consider this much 0.5, 2.5 times this copy. Okay, now we can find out the area of, suppose this copy. How much? 1. It's less than this, 1.5 times of this copy. So we can find out the area. Which, how can we measure? We have taken this as a standard one. Standard one. This one, no issue. This one, we have taken a standard measurement. If I say someone that area of my bed is, suppose, how much? 20 times of the copy of a standard copy. 20 times of a copy. I just told you. Suppose you are going to some friend house, and suppose you asked your father or some brother that I need a bed. How large do you want the bed is? You say that it should be 20 times of a copy. Okay, 20 times of a copy is sufficient for me. Then what happened? Someone, suppose, taken the copy of like this. Someone made a copy, a bed 20 times larger than this copy. Then what will happen? Can you sleep there? No, that will not be a perfect bed for you. So what should be the standard size? Whether it should be like this or whether... Yes. Whether it should be like this or it should be in other dimension. Here comes the units of area. How standard should it be? How large it should be? So from the above investigation, we can calculate that area of the table is more than that of the chair. Well, already we have experimented it through your copies. Now units of area. For measuring area, we must have some standard units. Suppose if copy, we have taken this copy as the standard unit, but copy, the size of the copy may be varies. You told 20. For 20 times of this size, it's perfect for you here. But if the copy is small, that will not be perfect. So in that case, we need a standard unit. The physics books which we use to measure the area of the chair are not standard units. It will sound foolish if you say that area of your table is equal to the area of your 4 physics books, as different physics books will have different areas. In standard international system, SI, the unit of area is square meter. In short form, square meter is written as meter square. Ama, so what is the standard unit?
Meter square.
Meter square. Meter and meter. Why meter square? Why don't meter? Why not meter cube? How did you find area? Can you remember?
By the surface occupied by the object.
How do you mathematically calculate area? Can you remember? What is the area of a rectangle?
Length into breadth.
Length into breadth. Into breadth. Length measured in meter, breadth also measured in meter. So meter into meter, meter square. Can you remember? That's why it is meter square. How big 1 square meter is? What is the area of the floor of this room? 1, 2, 3, 4 meter by 3 meter, almost 12 meter square of this room. So how big 1 meter square? If you can have idea of 1 meter square, then it will be easy for you find out the area of floor, area of your bed sheet. If you can find out your area of bed sheet, then you can buy it easily in shop. You can also buy tablecloth like this. So it will help you in your daily life. The area of a square meter whose each side is equal to 1 meter is called 1 square meter. But it said area laid in if length is 1 meter and breadth is 1 meter, then that surface is called 1 meter square or 1 square meter. Figure 1.2, a square surface ABCD, it says AB is equal to BC is equal to CD, D is equal to 1 meter. The area of the surface enclosed by ABCD is 1 meter square. It is not equal to 1 meter, actually it is 3 centimeter. It's considered as 1 meter. So like this, it's 1 meter square. Submultiples of standards of unit of area. SI unit is meter square. 1 meter square. What is the surface of this rubber? Surface area?
Less than 1.
Less than 1. It is very, very less than 1 meter square. So it will be something 0.003 meter square. So it is not convenient to use 1 meter square in such type of small object. So we need some submultiples of standard unit of area. Understand? What is the area of this? What is the area of your hair? You cannot even measure it in centimeters. You need millimeter, nanometer. Okay. So that's why we need submultiples of every unit. Meter, centimeter, millimeter, nanometer, everything is there. That's why it is actually for convenience to measure things, measure objects, we need some different we use actually different units. If you use meter in every object, whether in nanometer, when is this in this object, or in this object, it's perfect, it's okay. You can use only meter. You are right. But for convenience, we use centimeter, meter square to understand, to visualize the objects more clearly. 0.003 meter square, you cannot visualize it. If someone told you 3 centimeter square, you can visualize 1 centimeter by 2 centimeter or 3 centimeter. You can visualize this. You can imagine a object easily. That's why you use submultiples of standards of unit area. Square meter is the standard international SI unit for the measuring area. However, it is quite an inconvenient unit for measuring the surface of small objects like a physics book or an instrument box, etc. It is also inconvenient to measure the surface area of very small objects such as a 5 rupees coin, saving blade, etc. Thus, we use smaller units for measuring such saving blade, etc. Such areas. Such units are called submultiples of standard units of area. Square millimeter, square centimeter, and square decimeter are the submultiples of standard unit of area. 1 millimeter square is equal to 10 to the power minus 2 centimeter square is units. So 1 centimeter square, you can say 1 centimeter square. This much is 1 centimeter square. And imagine you can visualize it in your brain that 1 centimeter square is this much. If someone tells you that the area of this eraser is 10 to the power minus 4 meter square, everybody student will be puzzled. 10 to the power minus 4 meter square, how much it should be? That's why, for convenience, we use submultiples of standards of unit. Understood why you need, what is convenience, how can we visualize, how units helps us in visualize our real objects in day-to-day life. Okay, suppose 2.5 meter square, convert it to centimeter square. You have to convert this, like this is the formula, very simple. Okay, so multiples of standards unit of area. How do you multiple? For measuring bigger areas such as the area of big plot of land, area of town or city, meter square is a very small unit. There's a bigger unit such as acre, hectare, and square kilometer are used. Now, the area of our football field, if you measure in centimeter, it will be very huge quantity, huge number. In meter also you cannot, it will be not convenient. Some area of your city, football field can be measured in meter. It's a convenient, it is useful. Meter is more useful than this bigger unit. But area of Assam, area of India, area of ocean, area of lake. Lake is also meter can be used. Area of a river. In that case, you need some bigger unit. It's very easy to understand if you use bigger unit. 1 r is the surface area of square whose each side is equal to 10 meter. Generally, we don't use this 10 meter here. 1 r. You have to remember this. It is already in red letter. So 1 r is equal to 10 meter by 10 meter. Suppose you have a field, suppose 10 meter by 10 meter, it is volleyball field. Volleyball field is 6 meter by 6 meter. In one side 6 meter, in one side 6 meter. So like that, little bit more than that. 10 meter by 10 meter. That is called 1 r. So 1 r is equal to 10 meter into 10 meter is equal to 100 meter square. Okay. 100 meter square or 1 meter square is equal to 10 to the power minus 2 r. So you have to find out these relations. Very simple. 1 r. Similarly, 1 hectare is equal to 100 r. Okay, 100 r. So for measuring further bigger units such as the area of a district or a state or a country, even hectare is a very small and inconvenient unit. Thus, a bigger unit is used, which is called square kilometer. Kilometer by kilometer. How long it is this? What is the area of Kaziranga National Park? Find out this. It is written in kilometer by kilometer. How much kilometer? I could not remember because it's a huge area. 1 square kilometer is the surface area of a square whose each side is equal to 1 kilometer. 1 kilometer square is equal to 1000 meter into 1000 meter. 1 kilometer square is equal to 1 kilometer into 1 kilometer. Okay, like this. 1 meter square, 1 meter into 1. 1 into 1, 1 meter into meter, meter square. Okay, like this. 1 kilometer square is equal to 1 km into 1 km. 1 km is equal to 1000 meter. It is 1000 meter. So they had omitted one step because they considered that students is smart enough.
So am I stupid? Am I foolish?
Let's see when you'll attack these problems, exercise, then it will be seen how much smart you are. Formula for calculating areas on some regular surfaces. Square, what is the formula
Side
of
by side.
square? Side into side. Rectangle?
Length into breadth.
Triangle?
No idea.
No idea. Circle? Cylinder, sphere. We have discussed this square and rectangular earlier, and these are new for you. Triangle, circle, cylinder, sphere. You will get this in mathematics. In especially in geometry section, you will get this. Just remember this because it is in your book. So there may be some questions on this formula. Okay.
How do you get the minus 4 here? How do you calculate that it is minus 4 here, or it's minus 2, or it's minus 3?
Can you remember those things that 1 by 10 is equal to 10 to the power minus 1? Can you remember?
Yeah.
1 by 100 is equal to 1 by 10 square. It's okay. It can be written as like that. Can you remember? 100 means there 10 square, it's okay. 10 into 10, 100. 1 by 1000 is equal to 1 by 10 cube. Can you remember this? Now it can be written as 3. Okay, 1 by how many zeros are there? 4 zeros. Just okay. 1000 10,000 is equal to 10 to the power 4. 1 by 10,000 is equal to 10 to the power minus 4. This is the simple calculation. Okay, can you remember this? So that's why it is 10 to the power minus 4 meter. From here they reverse this 1000. Actually what they did it here, they has omitted one step. Here 1 meter square is equal to 1 meter square is equal to 10,000 centimeter square. Okay, divide both sides by 1000. 1 by 1000, 10,000 meter square is equal to 10,000 by 10,000. How much? 1. Understood? Divide both sides by 10,000. Okay, it will be 1 by 1000, and here it will be 1. This relation is this. 1 centimeter square is equal to 1 by 1000. Can you remember? Don't. This type of mathematics we have done last year. Dividing both sides.
Not in maths.
Huh?
Not in physics.
Not in physics. Physics and maths is same. The language of physics is maths. Generally, how we remember this? That if it is comes this side of equal to, then it becomes reciprocal of this. It is divided by this. If it is come here, then it will be divided by this. So we remember like that way, in that way. Okay. Suppose we want to find the area of the face of a big leaf, such as a peepal leaf or a banyan leaf. Place the leaf on the centimeter graph paper with the help of sharp pencil. Mark the outline of the leaf. Outline of the leaf. Just place the leaf here like this, my hand, and this outline. Mark the outline of the leaf here. Okay. Now count the number of complete square enclosed by the face of leaf in figure 1.3. The number of complete squares is 23. Complete square 1, 2, 3, 4, 5, 6, 23. Okay. Now mark the incomplete square with tick half and count them. Incomplete. These are incomplete. These include incomplete. And count them. The incomplete square are 27. Assuming the area of incomplete square equal to half square, the approximate area of the leaf in centimeter square.
It can't be half square. This is not half square. This.
Yes, you are right. This is not half. But this is more than half. Is not it? This is more than half. This is more than, slightly less than this, but it is more than half. Is not it? Slightly less than complete square, but it is taken as half. Is not it? These are complete square. This is taken as half. This is taken as half. If you consider this one and this one, this will make a complete square. So half of this and half of this will make a complete square. So that's why they have taken this as half of square. They approximate the number of complete square into half of that. So 27 into half. There are total 27 incomplete square. So this will be 27 into half, 13.5. Complete square 23 plus 13.5, 36.5 centimeter square. Okay, this is a way. And last year we calculated in another way, that whichever covered more than half of the square is considered 1, whichever covered less than half of the square is considered as 0. If you count, if you do in that way also, you will almost find out 36.5 centimeter square. Let's do it. Okay, 23 complete square. Okay, now we'll do 23 complete square plus, we'll consider these two. No, this will 1. We can consider 2. Will not consider this. 3. Will not consider this. 4. Not consider. Consider 5. Okay, will not consider this. 6. Not consider. 7, 8, 9, 10, 11, 12. And this one, should you consider this? 13. 23 plus 13. How much? 36. Look at this, 36.5. Is it a magic?
No.
It's not a magic. It's another way. So last time their method is different, and this time the method is different. But the accuracy level, look at this, 36. 36. Maybe if you count, maybe it may be 37 or 37. Maybe 37 or 36, maybe 35, but almost it is equal to 36.5. The method described above gives the area of the board leaf with fair accuracy. However, for finding the area of smaller leaves, we can use millimeter graph paper. Already I told that. If you smaller the size of the square, then you will get more accurate value. Millimeter graph paper means it will be in a millimeter scale. Okay, in this graph paper, area of each small square is equal to 1 millimeter square, and 100 small square will equal to 1 centimeter square. Millimeter graph paper. If you have some match copy, you have an image copy, you will get here the millimeter square. It's very small. So today we have finished discussion of this just area. What is area and different units. So next class we'll work out this exercise. Yeah, you have millimeter, this one is millimeter, so you have to place a rose leaf and draw the outline, and you have to find the area. Okay, thank you for today. We'll do this exercise next in next class.